The given limit is limit x tends to 0, sine of pi cos square x by x square. We have to evaluate this limit. Now, limit x tends to 0, sine of, I'll convert this cos square x into sine square x. Cos square x can be written as 1 minus sine square x by x square, which can be written as limit x tends to 0, sine of pi minus pi sine square x by x square, which can be written as limit x tends to 0, sine 180 minus theta is nothing but sine theta, which is sine pi sine square x by x square. Now, we know limit theta tends to 0, sine theta by theta is always 1. So, if it is theta, it should be theta now. So, look into the function here. Theta is nothing but pi sine square x. So, even in the denominator, it should be pi sine square x. So, we will multiply and divide by pi sine square x. Then the limit will be limit x tends to 0, sine of pi sine square x by pi sine square x into x square into pi sine square x. Now, I'll write it as limit x tends to 0, sine pi sine square x by pi sine square x into limit x tends to 0, sine x by x whole square. Now we know limit x tends to something, f of x into g of x will be equal to limit x tends to something, f of x into limit into g of x. Now, we know sine theta by theta is 1. So what will be this function? 1. So what will be this limit? 1 square, and we are left with this pi. So the answer is pi. That is option B.
In the above problem, we have to find out the steady state value of the above given expression. That means from the final value theorem, limit t tends to infinite, f of t is equals to limit s tends to 0, s into f of s. But the problem with the above final value theorem is that it is applicable only to the stable systems. That means final value theorem is not applicable to the systems whose poles lies on j omega axis or right half of S plane. For this particular problem, poles are located on j omega axis. Hence, final value theorem is not applicable for this problem. Hence, steady state value is not defined.
The given differential equation is dz by dx plus z square is equals to 0, which can be written as dz by dx is equals to minus z square, which is dz by z square is equals to dx minus of. Now, in order to find the solution, we have to integrate. So, integrating on both sides. So, if we integrate, integration of 1 by z square is nothing but minus 1 by z. So, which is nothing but 1 by z minus and minus, which is equals to integration of dx is nothing but x, which implies 1 by z is equals to x plus constant c, integration constant. That implies z is equals to 1 by x plus c. That is option D. The given matrix is A is equals to 6, 10, minus 2, minus 3. Now, we have to find the trace of A power 10. Now, first of all, let us see a property. if A is any matrix whose eigenvalues are lambda 1, lambda 2, lambda 3 and so on. Now then trace of A power n will be nothing but sum of all the eigenvalues raised to the power of n. So lambda 2 power n plus lambda 3 power n plus so on. Now in order to find the trace of A power 10, first we have to find the eigenvalues of A. Now in order to find the eigenvalues, we'll consider 6 minus lambda 10 minus 2 minus 3 minus lambda is equals to 0, which is nothing but the characteristic equation. If we simplify this, we'll get lambda minus 2 into lambda minus 1 is equals to 0, which is nothing but lambda 1 is equals to 1 and lambda 2 is equals to 2. That is, the eigenvalues are 1 and 2. Now according to the property, trace of A power 10 will be lambda 1 power 10 plus lambda 2 power 10, which is 1 power 10 plus 2 power 10. That is nothing but 1025. Option D.
Question is find out the Laplace transform of a sine 3 and cos 2t. Right. So here the option A and option B and option C and option D are given. Okay. So here we have to find out the Laplace transform of sine 3t and cos 2t. Okay. And if you want to directly solve with the help of this, and it is very difficult, so we can convert this into a feasible form. So we can convert this sine 3t cos 2t into a feasible form first, then we have to apply the Laplace transform, right? So this is our f of t. So we have to find out the Laplace transform of f of t. So we'll get f of s equal to something, right? So before doing that, first we have to apply, we have to go for trigonometry and we have to recall our trigonometry equations. We know that 2 sine A cos B is equal to sine of A plus B plus sine of A minus B. We know this equation, right? So now I am converting this sine 3t and cos 2t to in this equation. So right, but here 2 times is not given. That's why sine A cos B. So sine A cos B equal to 1 by 2 times sine of A plus B plus sine of A minus B. That means this equation, right? Now I am converting this. So sine 3t cos 2t equal sine of A plus B. That means 3 plus 2. That is A equal to here 3t and B equal to here 2t. So that's why 3t plus 2t. How much will get? 5t plus sine of A minus B. That means sine t. Now the Laplace transform of sine of 5t plus sine t. We have to find out this. This is equal to Laplace transform of sine AB. So we know that Laplace transform of sine AT, Laplace transform of sine AT equal to A by S square plus A square. So with the help of this formula, we have to find out the Laplace transform of this. This is equal to 5 by S square plus 25. So here 1 by 2 is there, right? 1 by 2 times, right? 1 by 2 is there. So that's why 1 by 2 times S square plus 25 plus, now the Laplace transform of sine t is what? This will be 1 by S square plus 1. So the option will be 1 by 2 times the 5 by S square plus 25 and 1 by S square plus 1. So if you go for the options, and the option will be here option C. Option C will be the correct answer for this problem. So here first important thing is we have to recall the trigonometric equation, this equation. If you know this equation, the answer will be very simple. Otherwise it is not a simple one.